Hello, everybody. Welcome to Hangar Day. We're so excited to have you all here. We know that some of you have been traveling from very far all over the world to get here today. And to deliver the opening remarks before we get started, we actually have a guest that came here actually on an electric plane. I don't think any of you else have done it, so I'm happy to welcome our big supporter and friend, our Minister of Infrastructure, Andreas Karlsson. Welcome up on the stage.
Thank you.
Thank you.
Thank you, Anders, and thank you all. It's a pleasure to be here today to actually see the future with our own eyes in the hall next door, in the hangar next door. And Anders, he's absolutely right. I arrived with an electric plane just this morning from Landvetter to Säve, and I had the opportunity to actually try to steer it a little bit. My own Måns from Swedish Aero Club was my co-pilot, I could say. Thank you very much for that experience. And this is not just the future. It is for real at the moment, and it will be in place in the market in just a few years with electric aviation. And today we witness exciting advances in electric aviation. And it's truly gratifying that this is happening here in Säve, here in Gothenburg in Sweden. This underscores Sweden's position as leading nation in aviation research and industry. And as a Swedish infrastructure and housing minister responsible for aviation, I'm a little bit proud, I must confess. An efficient, functional and climate-friendly transport system must include all modes of transports: road, rail, shipping and aviation. In a vast country like Sweden, aviation is vital for domestic travel, to connect people. It's a driving force for our economy, and it's enhancing our global openness. Despite aviation's importance, it has been deprioritized for years. And despite the ongoing transition that we can see with our own eyes, we have had concepts like flight shame. And I will say today, and I've said it before, once and for all, we need to abolish the flight shame. We need to embrace the opportunities, embrace the transition, and pioneer the possible. And that's what Anders and his team are working day and literally night to succeed with. And we are, my government and I, we are committed to reversing the trend we have seen in Sweden, also on a global scale for a while, boosting competitiveness and transitioning to fossil-free fuels in the aviation sector, electric aircraft, and smarter flight procedures. Airports are also a priority for my government, and this year we are doubling the government grants for regional airports while requiring those receiving subsidies to actually work towards fossil-free operations. We recognize the urgent need for climate action, but it must happen within a growing economy. It's actually possible to reduce emissions and work with competitiveness and create job and wealth at the same time. A successful climate transition requires that individuals and companies can act, invest and produce in more sustainable ways, increasing overall prosperity. In this context, it is crucial to create the best possible conditions for airlines, airports and aircraft manufacturers to contribute to climate efforts. As aviation is a global industry, international agreements and regulations are essential, and the EU is leading the way, and during the Swedish presidency, significant strides were made in reducing aviation's climate impact, such as ending the free allocation of emission rights and mandating the use of sustainable aviation fuels. To further enhance the sector's competitiveness, and to do that, the government has proposed abolishing the Swedish aviation tax in the upcoming budget. Eliminating this tax will also boost airlines' ability to invest in climate-smart technologies and strengthen connectivity and the competitiveness for airline and airports in Sweden. And talking about the planes, this construction of the aviation tax actually hits both planes that are driven by sustainable fuels or electric airplanes in the future as hard as those without. So it's no incentives at all for greener flights, and that's not reasonable. Dear friends, Sweden is well positioned for electric aviation. This transition will create opportunities for new routes, especially between smaller regional airports, and improve connectivity with our closest neighbors. We also see opportunities on a global scale, but we think we will start with our Nordic countries, counterparts, our neighbors. And for 1 month ago or so, I gathered my Nordic minister colleagues here in Gothenburg, and we signed a declaration to promote and support electric aviation in our different countries, and doing that together to actually create the market and to start with aviation in the air with electric planes as soon as possible. So the regulation and regulatory work will already start, and to go in the same phase, hopefully, as the innovation part of that you are leading, Anders, and the team here. So my government is committed to removing barriers and supporting the development and commercialization of electric aviation. We agreed with the Nordic countries to support our industries in becoming world leaders in key technologies related to electric aviation. And Anders, to end with, I want to thank you for what you and your team has achieved so far. I will thank you for the good cooperation and that we can work so close with the government and the business. We are closely following Heart Aerospace development and see great potential for its future production facility to be established in Sweden. And Heart Aerospace's groundbreaking work in electric aviation inspires me. It inspires and gives hope for a fossil-free future with stronger connectivity. So I wish you, Anders, I wish the company and all here today great success in the work ahead, and we will stand with you and work together to pioneer the possible. Thank you.
So thank you so much, Andreas. And we've had this great collaboration with the Swedish government and with the Swedish Innovation Agency since the inception of the company, and we will show a little bit more. The things you're going to see here today is actually the result of some of that collaborations. But again, welcome here. We're really excited about the thing we're going to show here today. We've been looking forward to this day for very long, and as I think you've heard already, the team has been working literally around the clock throughout the summer to get ready the thing that you're going to see on the other side of that door. And Hangar Day, this concept, it means a lot to us. Because when we started this company, it's about 5 years ago, we had nothing more than a vision. And we quickly wanted to provide, to set goals for ourselves and to hold ourselves accountable to be delivering tangible proof that we're tracking towards electrification of aviation. So this is the third of these events. And at our very first event, we had only when the company was 1 year old. And this was a small event. It was held over there. And it was mostly a Swedish affair because not many people internationally had heard of us. And we were a small team of about 10 people. But we really wanted to show the first puzzle pieces, the first stepping stone to show this sort of electric future. And we showed our full-scale propulsion demonstrator that was essentially an electric motor and a battery system that was the scale of a small turboprop jet engine, and also our subscale flight model that we later flew. And this event sort of triggered something. And quite shortly after that, we started getting orders from some of the largest airlines in the world, including United Airlines. We started getting investments from some of the most influential and prestigious climate investors in the world. But most importantly, we started getting an influx of talent moving here to Gothenburg from all over the world to join our team and make this a reality. So 2 years later, the Hangar Day event was quite different. We had the airline partners from all over the world, and we introduced the ES-30 hybrid electric aircraft. And we also showed the next puzzle piece, the next stepping stone, which was our ITF, our integrated test facility, where we had not only the electric motors, but all the other subsystems on board, including flight controls, avionics, and we could even fly this plane on the ground, hardware in the loop. We also had a separate cabin mock-up where we could bring our partners in to look at what the user experience would be. So these were 2 more puzzle pieces that we sort of laid out there. And now, today, 2 years later in 2024, it's even more exciting. Today, we don't only have guests from all over the world, we also have a multinational team, which is both working from here in Sweden, but also from Los Angeles. And you'll be hearing from some of our new team members later today. And as you all see, the team is actually lined up right here up on the balcony, so say hi to... So today we're putting all of those puzzle pieces together, and we're doing the thing that we started this company to do, and we're going to be unveiling our demonstrator aircraft. So we're going to get to that very soon. But first, we want to talk a little bit about why we're doing this. Unfortunately, as HARD has gone through a change in these last 5 years, so has the climate. When we started, we had about more than 30 years to 2050, when aviation is looking to be net zero. And we also had the 1.5-degree goal that seemed that we had a plan, and it was within reach. But today, actually, we've gone more than a year above that critical threshold on 1.5 degrees over pre-industrial levels. And aviation has already spent its carbon budget, what was allocated for aviation to make its share for 1.5 degrees. It's already committed emissions with the in-service fleet. This is a report from the ICCT, and if we want to be at net zero, we'll have spent all of our net zero carbon budget, not by 2050, but by 2032. And that means that all new aircraft delivered after 2032 needs to be net zero. And if we want to be at the 2% target, we're at 2038. So when we talk about aviation, it's not a problem for the decarbonization of aviation. It's not a problem for 2050. It's a problem that we have to solve in the next few decades. And we fundamentally believe in order to have a chance for all new planes to be net zero in the 2030s, we need to have the first net zero planes already in this decade. This is probably like the biggest challenge the aviation industry has faced, but we don't think that it's undoable. It's not unprecedented, but what we believe that we need to do to overcome this hurdle is a paradigm shift. And we look at these paradigm shifts from 3 different aspects. We need to innovate on propulsion and create new architecture that pushes propulsive efficiency further. We need to innovate on how we do product development so we can get these new technologies on market faster. And we need to innovate on production, build a new generation of facilities to build the next generation aircraft at scale. So we really believe that this can be done. And we want to sort of, before we start looking at our aircraft, we want to go through this, give some historical context on aviation and perspective from other industries that have actually been further along on their journey towards propulsion is the lifeblood of aviation, and it's been the advances in propulsion that have pushed aviation forward, and it was in fact a revolution in propulsion that got aviation off the ground in the first place. It's 120 years ago that the Wright brothers flew at Kitty Hawk, and they made two core innovations in propulsion. They built a lightweight aluminum engine, and they built the world's first airfoil-shaped propeller. And this was a historic moment that obviously set off a development that came in a breakneck pace. And only 30 years later, we had propeller aircraft like the DC-3 flying in commercial service and sharing some of the similarities with the aircraft that we see today. But 10 years later, we had the first paradigm shift in the aviation. During the Second World War, we saw aircraft such as the Lockheed P-80 that were the first generation fighter jets that actually used jet technology. And the progress accelerated. So within the next 10 years, we saw a transition to the modern jet airliner. So the Boeing 367 experimental aircraft essentially shared most of the characteristics with the aircraft that we still fly today, 70 years later. So this all happened very, very quick. It was a period of fast iteration and new concepts. What's happened since? So we look at the next 70 years, it's been something that's been equally remarkable, which is that we've looked at this jet engine technology and we've focused on lowering fuel consumption. And we've essentially reduced this in half, going from about 7 liters per 100 passenger kilometers in the 1960s to about 3.5 now. So this is great. This is a remarkable achievement. But unfortunately, looking forward to 2050, we cannot extrapolate this development to net zero. We can't really build jet engines that consume no fuel. That's against the laws of physics and thermodynamics. And in fact, what's happening is that we're seeing a curve of diminishing returns. And with every new investment in optimizing jet engines more, we have to get just the 0.1% more, we need to spend 10 times as much as we did to get the last 0.1%. We're sort of starting to hit a wall here. And at the same time, the emissions are expected to triple. Because globally, aviation is only in its infancy. There's 6 billion people that are looking to be connected to this infrastructure. And it means that we're growing at a pace of about 5% every year. So looking at this graph again, what is it that we need to do? We need to do something different. And this is not controversial. In fact, the entire industry agrees that this technological shift needs to happen. For instance, Boeing is stressing the need for a substantial technological leap to justify a new aircraft program. That's why even the large OEMs and the large incumbents are looking at hybrid electric and hydrogen solutions. But they're not expecting this technology to get off the ground anytime soon. In fact, the headline of this news article was that we do not expect a new clean sheet aircraft happening this decade. And in fact, both Airbus and Boeing have since said that they expect the next clean sheet aircraft to come first at the end of the 2030s. This is quite concerning, not only because we showed before that we're going to reach the end of our budget by 2032 or 2038, but also because we're approaching a 30-year innovation cycle in aviation. This means that engineers are losing their currency in designing and developing new aircraft because they're not getting the repetitions in. And then in the 2030s, we're going to build this one aircraft that is going to sort of decarbonize it all at once. We believe that that is extremely challenging. And if we want to take sort of a page from the Apollo project, we believe that in order to get to the giant leaps, we actually need the small steps. And that aircraft that you're here to see today is what we believe is that stepping stone towards this paradigm shift. So I'm going to show it over here. first, we're going to just look at a render. This is the ES-30 hybrid electric aircraft. It's an aircraft that does not require a technological leap to be a reality. And it's through a concept that we unveiled a few months ago that we call the independent hybrid system. And we're going to show you a little bit about how it works. So, in the rear fuselage of the aircraft, there is a large battery. And that is in an all-electric system running 2 electric motors that are pushing this aircraft forward and are propelling this aircraft. This works exactly in the same way that the plane that is already certified, that Andreas flew in here today, works. It's also the same technology that we demonstrated 4 years ago, and there's not a lot of added complexity. But outboard, here you see on the wing, we have 2 turboprop engines. This is off. This is actually not this is not turned on for flights under 200 kilometers, and the propellers are feathered, which means that they're not causing a lot of drag to the airframe. But if we want to fly a longer route, or if we need the reserves, if we get redirected to another airport because there's an issue on the ground, we can turn this on in the cruise segment of the flight. And then you have these 2 systems operating independently and in parallel. You can even go so far that in the cruise phase, you can turn off the electric motors and fly only with the turboprops, allowing this aircraft to be ferried across even longer distances. This is a very simple solution, and it's built with puzzle pieces that we have today. It does not require a technological leap. And the exciting thing about this aircraft is that it creates really good performance. It seats 30 passengers. It has a luggage capacity of 25 kilos, which is more than the industry average. It flies 200 kilometers or 125 miles in an all-electric range. It can fly up to 800 kilometers in a hybrid range with 25 passengers. It operates from short runways, so 1,100 meters, or actually even less. And it can charge in about 30 minutes. The exciting thing about this concept, the independent hybrid, is that it's not just a good all-electric plane. It actually has substantial emissions reductions, both for the short flights, the ones that are up to 200 kilometers, where we virtually eliminate emissions, but even for 400 kilometers, we have less than half the emissions. And at 600 kilometers, we have eliminated about 1/3 of emissions compared to the best, most fuel-efficient turboprops we have out there today. So that's why we're so excited about this solution. And the other thing that's really exciting about this is that given that this is so good for long ranges, we think that this will transition into 2 different categories. One is the regional all-electric category, where we work in these sort of 30-seat segment, and we start pushing the all-electric range further and further, eventually actually being able to eliminate the turboprops altogether and fly all-electrically. But one is also to cross over to a much larger segment, which is the crossover narrow-body market, and build aircraft that could seat 100 passengers or more and fly longer flights, still operating with the takeoff and landing that's all-electric, but not really having the significant operating range all-electric, but instead focusing on reducing the emissions for longer flights. And that kind of aircraft could be combined with SAF, play a major role in decarbonizing the larger narrow-body market. So the ES-30 is developed in partnerships with the airlines that fly it. We have, since the start, worked with our industry advisory board. These airlines are not just our customers, they're our investors, they're our advisors, and they're our friends. And to tell you more about how we work with the industry, I invite our president and Chief Commercial Officer, Mr. Simon Newitt.
Thank you, Anders. Thank you very much, Anders. It's obviously great to be here. Thank you all for coming. It's a real pleasure for us to be presenting an update to you today. So, in terms of the advisory board, we launched this exactly 2 years ago. And it truly has lived up to all our expectations in terms of the commitment and the efforts that all the partners are making in the journey towards electrifying air transport. The airlines, the airports, the leasing companies, the governments, all showing incredible amounts of support in making this become a reality. So since the launch, this board has come alive. So we have regular meetings discussing the different aspects of aircraft design and the functionality of the ES30 on the ground and in the air. Some of these meetings have been in person, you can see here. Some of the meetings have been online. We have our dear colleague showing how big his is, up there on the top left, in terms of charging. I think the common theme from all the formats of the meetings have been really the amazing engagement that we've had, the unbelievable participation from all the partners, and the incredible and valuable input that we're getting that's helping us on our way in terms of progressing the program. So the advisory board for us is absolutely fundamental, and we're so appreciative for everything that's been happening to date, and we're excited about the future. So in terms of sharing what are the sort of key highlights over these last couple of years, I'd like to focus in on a few major milestones. The first one I'd like to draw attention to is Air New Zealand. Now, Air New Zealand selected Heart Aerospace as one of their long-term strategic partners in a project that they call Mission Next Gen Aircraft. So what this basically is a project whereby they help support the acceleration of zero emissions aircraft technologies, as well as all the infrastructure that's required to enable these technologies to become a reality for commercial aviation in New Zealand. So we're deeply honored to be a partner of Air New Zealand. But I think one thing that's really important to mention here is the partnership with New Zealand as a country. So we talk about the ecosystem, the importance of the collaboration between all the key stakeholders, the OEMs, the airlines, the airports, the regulatory authorities, and the governments, and other stakeholders, energy providers. New Zealand is a very good case in point. So we're not only honored to be part of the Air New Zealand project, but we're delighted that we can be a solution for a country such as New Zealand's sustainability ambitions. Another main highlight for us over the last months has been the decision that came from United Airlines and Air Canada in essentially deepening their investment into Heart Aerospace during the B round that we closed earlier this year. I mean, both of these are leading airlines of the world, walking the talk, basically putting their money where their mouths are, showing incredible and active support into everything that we're doing. So we're deeply appreciative of everything that Air Canada and United Airlines do for us, and we look forward to the partnership growing from strength to strength going forward. And of course, a lot of activity as we've been welcoming new partners to the advisory board, new members to the Heart family. So you can see here some marquee names in Europe, such as KLM. We have our KLM friends with us today. The Lufthansa Group, IAG. From outside of Europe, you see other jurisdictions showing interest in the program, other airline business models, such as Vietjet Air from Vietnam. And then in the US, we were very proud to announce a partnership with JSX. JSX joined the board, but they also signed an LOI with us for up to 100 ES30s. Now, 100 ES30s is a lot of aircraft, so I think we should spend a little bit of time on discussing that. What I'd like to show you here This is JSX's work. So behind me, you can see a future network route potential that JSX sees as possible only because of the lower operating economics that the hybrid electric airplanes can offer. So we often talk about points on the map, airports that exist but don't have service anymore, or have service levels that are so low that it's really not sustainable. And airlines are crying out for a platform that delivers on an economic proposition whereby all these routes can start to see a regeneration. So when we talk about the S30, we're not replacing old equipment only, we are creating new market potential. So JSX sees that, and they see the ES30 as being able to deliver on that economics, which will then allow them to grow and develop their network across the US. So we're very delighted about this partnership and actually look forward to materializing that 100 aircraft LOI and seeing at least 100 ES30s plying the route network that JSX has identified at this moment. Speaking of airports as well, I'd like to acknowledge additional airlines that have come on board, the advisory board over the recent months. Special shout out to Auckland Airport and Copenhagen Airport. The importance of having airports can't be underestimated. As part of the dialogue as we develop the program, we need to be successful in operating and turning around these aircraft. So airport input, airports wanting to know what they should be investing in, what is the technology they need to be considering is absolutely vital. I think I'd like to do a special shout out also to our friends at Swedavia who are also here. I think it's fair to say that we probably speak to our partners at Swedavia every other week. The teams are talking. We're working on a lot of projects together. So even outside of the advisory board, there's a huge amount of engagement at the airport level. Now, a hangar day wouldn't be a hangar day if we weren't to announce a new partner. So it gives me great pleasure to announce that AirAsia has decided to join our advisory board. Now, for those of you that don't know, AirAsia is the 4th largest airline in Asia. They've been around for a little over 20 years. They're the ones that basically have brought the whole low-cost operating model in the airline business to the region, and they've done it extremely well. They operate literally hundreds of narrow bodies across a number of Asian countries, and we couldn't be happier to be partnering with them. One thing that really resonates with us when we talk to the founders, when we talk to the management of AirAsia, is their deep-rooted focus on their mission, which is to bring affordable air transport to everybody. That's been really the fundamental driver behind AirAsia, and it resonates very much with us because it's obviously a driving principle in the democratization of air transport. So this was us last week. So Claudio is our head of marketing. Claudio already with his sleeves rolled up. This was us signing our partnership agreement. The gentleman on the left-hand side, gentleman up on that side is Captain Lau. He's head of air safety at AirAsia, and he's going to be the representative for the airline on all our board meetings and working groups going forward. Just a small footnote on AirAsia. They hold I would say the proud recognition of having one of the lowest unit costs for any airline in the world. So when we talk about bringing an economic proposition to market, who better to have at our table than AirAsia, who is absolutely obsessed with driving costs down. So we're super excited about AirAsia, but it doesn't stop there. So last week was a busy week for commercial traction, where we also announced Loganair. We announced a collaborative agreement with Loganair, an exclusive collaborative agreement. Now, this is very exciting for us as well, and as a Scotsman, one that I'm particularly proud to be talking about. Now, Loganair, we've talked about AirAsia being a low-cost regional low-cost carrier in Asia. Here we have a regional airline flying in the UK. Loganair have been around for over 60 years. They have a rich heritage in regional operations. They've flown almost all types of regional aircraft, from 9-seaters to 19-seaters to 50-seaters to over 70 seats. They've operated jets and turboprops. They also operate some very particular operational missions. So a bit of fun fact for you guys. The world's shortest commercial route, which is 1.7 miles, is flown by Loganair, which is between two islands in the Orkneys. And if that's not enough, they also fly the only scheduled service from Glasgow to an airport that has as its runway a sandy beach. So they operate twice a day to the island of Barra, which is on the west coast of Scotland. So look, Loganair has a rich heritage. Regional operations are in their DNA. So we're so excited to have them as a partner on the advisory board. But it's more than that. It's an exclusive partnership. It's a collaborative effort where the two companies are going to engage with the ecosystem, engage with the Scottish government, engage with the airport authorities to develop a use case that can then be turned into reality in a short distance in the future. So this formula of ecosystem play, we talk about it in New Zealand, we talk about it here in the UK, we talk about it here in Sweden. We've had the minister just opening our event. We have excellent work that's been going on that you'll hear about with SAS, with Brathens, with Swedavia. It's this way of working together that's going to pave the way for the successful introduction of these aircraft in the future. So to Luc Farajala, the CEO of Loganair, our gratitude and our appreciation, and thank you for your leadership. And before I hand it over to Ben, I think it's appropriate that the last words of my update are given to Luc. So thank you very much.
So first of all, thank you very much indeed for giving me the opportunity to speak to you. And I'm so sorry I can't be there in person with you in Sweden today. As you're watching this, I'll be enjoying myself on a long-earned period of vacation for a week. And so I'm sorry I can't be there, but I'm with my family elsewhere. But I really hope that the day that you have today is informative and that you all get something out of it. I'm really excited on behalf of Loganair. We're really, really excited about this partnership. At some point, there's going to be an emerging technology. And we feel that much as in the same way that the ground transportation, car transportation network moved towards a hybrid solution initially on its journey towards fully electric, we think there's a good chance that that could be the case with aviation and with air travel. And right now, we think that the size of aircraft that's being developed, we think the specification, we think that the technology that's being utilized by HARP, we think that's quite appropriate and quite complementary to the way that we look at the future generation of regional aircraft and regional airlines. And we feel, therefore, there is a good chance that hybrid technology could be the market leader in the coming years.
All right. My name is Ben Stabler. I'm the new CTO at HART. I just started a few months ago. Before HART, I was working on autonomous battery electric freight vehicles at a startup in Los Angeles. And prior to that, I worked on manned spaceflight at SpaceX. And I'm here to talk about how we're going to add rocket fuel to our product development process. So in the early days of aviation, there was tremendous innovation with teams working at breakneck speeds to build radically new aircraft to market. So the aircraft that you see here is the XP-80. So this was a prototype aircraft developed by Kelly Johnson's team at Skunk Works at Lockheed. And this turned into the P-80, which was the first operational jet fighter in the US. And this aircraft was built by Kelly's team in just 143 days from clean sheet to first test flight, 143 days by a team of about 130 people. And Kelly wrote about this plane in his autobiography, and he knew that in order to develop this aircraft on that tight schedule, the only way he could do that was to eliminate all possible sources of friction in the product development process. So he took his team There's about 28 engineers, 130 people. He put them all in one room, put them next to the wind tunnel, optimizing for design, build, test. And nowadays, if you want to build a jet aircraft, there's a very sophisticated ecosystem that didn't exist in the time of the XP-80. So there's many distributed, specialized contractors that develop components, and then the airframer acts primarily as an architect, system integrator, and the project manager. But this is challenging, and it results in slow feedback loops because you're integrating the components at the system level relatively late in the development process. So if there's any residual technical risk, you're going to see schedule and cost overruns. And so if you're trying to build a radically new aircraft like the Hart ES-30, an electric aircraft, it's not a great structure. And a lot of people think that innovation has slowed down because of the regulations and how the regulation drives a V-model approach to product development. But really, you're operating in this highly fragmented ecosystem. And the ES-30, when it flies, will be the first hybrid electric commercial aircraft to enter service. And so in order to develop this aircraft, we're going to be adopting a spiral development process where we're designing the aircraft and the components simultaneously. And this allows us to take control of the development of key systems and verticalize where it makes sense. And so we can test early and often at the system level. And so this is how we're going to deliver an aircraft to market cheaper and faster than if we were to follow a typical modern design methodology. And so I want to talk about some of the technical innovations, just spotlight a couple examples here. So what you see on the screen here, this is a new nacelle design that we've developed here at Hart. And this nacelle design increases the maximum angle of attack of the wing by attaching a vortex as we increase the angle of attack. And this is not specific to the Hart aircraft. In fact, this design could be leveraged on other aircraft with a similar wing configuration. And this allows us to reduce the fall speed of the aircraft, which means that we can operate from shorter runways. And the engineer who designed this, Elaine, is here today. And when we go into the next room and take a look at the aircraft, he'll be there to answer questions about this. In a few minutes, we're going to go see the Hart X1. So this is our first experimental flight test vehicle. It's an all-electric vehicle, and it's built here in Gothenburg by the team that you see up on the walkway. And when we fly this aircraft next year, this will be the largest electric aircraft ever flown. We're going to follow this aircraft up with the Hart X2. And the Hart X2 will include the turboprops. It'll be a hybrid aircraft, and we'll demonstrate our hybrid electric flight with that aircraft, demonstrate the range that we can achieve with that configuration. And we're going to be developing our core systems, our components along the way. We're going to be iterating on our core systems. And so this is going to prepare us to step into a period of rapid iteration on our conforming prototype of the ES-30 following the Hart X2. We're also developing software. So we're pleased to announce just recently, a couple weeks ago, we received the news from the FAA that we're one of the recipients of their FAST Fueling Aviation Sustainable Transition Grant. So we're going to be, we're a recipient, we received about $4 million. We're going to be using that to develop software which allows us to automate the dynamic adjustments of our parallel hybrid propulsion sources on board the aircraft. And in preparation for next year's test flight, we're going to be doing extensive testing on all of our systems. Testing will be happening on and off the vehicle. This work is already ongoing. And I know that everyone here is really excited to see the plane. We've got a few more topics to discuss before we go through the hangar doors. The aircraft that we've built has been the hard work of everyone that you see up on this balcony, the entire Hart team. So let's have another. So before we go see the actual aircraft, we have a video here which highlights some of the great work that the team has been doing.
Designing an aircraft and also building a team at the same time was kind of a crazy idea, but also insanely interesting and fun. The part count on this thing is insane. Finding good ways to do this in-house has been key. You know, we didn't have to wait. We didn't have to rely on others. We can change things. We can work a little bit more. We can be agile. We're dependent on ourselves.
Do you have any idea of like when we're going to take off? Because I see they haven't put the propellers on yet. Is this a maintenance thing happening right now?
It's been really important to have fun. I mean, if it's only work, you're not going to get there. It needs to be more than a workplace. Without the team, we wouldn't be able to stand here where we are today. So this is a combination of all our work so far. Our first full-scale prototype. This is Heart X1. This is the future of air travel. This is the future of aircraft production.
As you just saw, the team has been doing amazing work to build a plane. At Heart, we're doing more than just building a plane, we're creating an ecosystem. Hi, my name is Nikki De Leon. I'm a high voltage engineer here at Heart. My career started when the electric vehicle industry had just released its first mass market EV. The Nissan Leaf boasted a 24 kilowatt-hour battery with a whopping range of 115 kilometers. That soon sank to 80 kilometers as soon as you hit the highway. Unfortunately, there were not a lot of charging stations available, just a few fragmented sites, and those maxed out at 50 kilowatts. We thought this was cutting edge at the time. But fast forward to today, and we have a robust network of electric vehicle charging stations that max out at 350 kilowatts. That's 6 times faster than those early charging stations, and many amazing electric vehicles on the market. More recently, I spent 7 years at Tesla. I worked on programs including the Tesla Semi charging solution. And for those who are unfamiliar with the Tesla Semi, it's a 20-ton vehicle fully loaded. It has a 1 megawatt-hour battery and has an 800-kilometer range. What was most exciting for me was that we had the charge to recover 600 kilometers within 30 minutes. That meant we would have to have a 1.4 megawatt charger. That is 30 times faster than those early charging stations. I remember the first time that we went to visit a customer site. It was located in Modesto, California, a town far from many other towns and far from substantial utility connection. There are 2 types of customers in the room. One who was very excited about this new technology, but the other who was apprehensive about what it meant to integrate this to their well-tuned fleet. The facilities team had a tight ship to run, delivering chips to their hungry customers, and I used this as part of my inspiration in my charter that we would not only deliver a well-engineered vehicle, but also a seamless charging solution that enabled the team to do their job to the best of their ability. At Heart, we believe that charging is a key enabler. It's not just about solving for the flight, but solving for the 30-minute turnaround on the tarmac. At Heart, we are working to create the whole ecosystem. Our team is thinking through the complexities of common charging capabilities across many airports and lead times for utility connections. Just as last week, alongside partners Vernova, SAS, BRA, and Svidvia, we hosted the first ever turnaround test of an all-electric regional aircraft. Just last week, here in this hangar, we completed the first ever charging demonstration of a megawatt charging connector on an all-electric regional aircraft. And next year, we plan to stand up the first megawatt charging station at an airport here in Sweden. At Heart, we're leveraging the lessons learned from our sister industries, but we're also working closely with our stakeholders to ensure that we tailor a solution custom for aviation. With that, I'd like to share a clip about the work that our team's been doing. Thank you.
Today we're gonna investigate the turnaround time for the X1 aircraft. As we have been in Landvetter and we saw how the ATR aircraft is being serviced and how the turnaround time for the ATR is going on, now we're going to simulate that for our aircraft. We're going to have luggage, passengers, fuel, and also charging. This will give us an idea of how this system and this aircraft compare to traditional.
It allows us as an airport operator to ask those questions that we want to solve before we have electric airplanes on the ground, but it also allows us to see the opportunities that we have with electric aircraft.
This is a great opportunity for us as airport planners and infrastructure owners to be part of the development of the aircrafts in an early stage.
Being able to evaluate different processes that are extremely important, that they work in our everyday, it's so extremely exciting. From a personal level, I feel that this is very, very, very important.
With the knowledge we have and all the experience we gained here, I'm really, really positive, and I really believe that we are not far away to actually putting this aircraft in the air.
That was a really exciting day, and actually you saw some of the passengers were actually members of the HART team. So they got to interact and really understand what it will be to be one of these aircraft in the near future. And so will you in just a few moments. But before we go into that, we want to look a little bit towards the future. We've talked a little bit about how we think our propulsion system is revolutionary and how we're working with airlines to make sure we're building the right product. We talked a little bit about our product development processes and how we iterate to get to market faster. But we also want to take a little bit of a sample, talking a little bit about how we're going to go forward, talking about production. So, when you looked at this certification roadmap from Ben, you see that the X1 that we've worked on now, that you're going to be seeing, that took us more than a year. And we're going to work with a similar process to build the X2, only employing some more pre-production technologies. But once we get here to the ES30, something is happening. There's a step change, right? All of a sudden, we start being able to produce aircraft at about a 10x improvement in speed, and we're also working in a conforming environment, bringing this aircraft to certification. So that is going to be a significant challenge. And as Ben mentioned, if you're working too much in the traditional approach, the lead times for sending out proposals, doing design updates, and operating in the traditional supply chain becomes very, very challenging. We're going to be working closely with our suppliers also in this process, and we have really great partnerships, including with Garmin, who's here today. But for the structural design and the propulsion design, we need to look at a different way. So for the past few months, we've been engaging a little bit upstream in the supply chain, speaking to those that make the carbon composite materials, those that build the machines that do the automated layup of those materials, those that build the digital backbone, the industrial backbone of Industry 4.0 that ensures conformity, and also with our certification authorities to really ask the question, what does an aerospace factory in the 21st century look like? And so we've created this concept we call the HART Pilot Factory. It looks like this. So what I'm going to focus a little bit now is on the structural sub-assembly element of this factory. So we can start by looking here. For the X1, when we build the wings and we build the fuselage, we build them in sections, and we do manual hand layup, a process that can take months. Using modern automated fiber placement machines, you can make the whole wing or the whole fuselage section in one go in the matter of hours. You could also use next generation inspection techniques, including non-destructive laser inspection, to make sure that the composite manufacturing, the composite parts that you're building are also conforming to your standards and that they are within tolerance with the sub-millimeter precision. We can also use machines for automated trimming and finishing of surfaces. And with this, we think even in our pre-production, we can get to about 1 aircraft a month. We also really love how we've been dealing with the painting for our aircraft. And instead of painting the whole aircraft after it's finalized, we want to innovate on the process where we paint the aircraft in parts, which means that one of the most least green of the technologies that you're using in an aircraft facility actually can be made in a much smaller footprint and more easily be made automated. So that little box there is the paint shop, and that's where you see the finalized fuselage and also the wing sections coming out. This is still early work, but we've already started ordering our machines. We're going to be building some of the first demonstrators for this in this hangar here. But after that, we're looking to build this factory from the ground up. And we're currently super excited about the discussions that we're having with a bunch of stakeholders about the construction and the financing of this assembly. We believe that this type of pilot plant could revolutionize aerospace manufacturing. It's a fully verticalized manufacturing of type-conforming aircraft. Uses automated composite layup, inspection, trimming. Throughput about 1 aircraft per month in pre-production that could go towards 1 aircraft a week in production. It's all Industry 4.0, so you have automated inspection, you have digital twins, so you can ensure conformity and certifiability. You can modularize this as well. So this becomes like the smallest unit, so you could expand it if you want to go to a large-scale production. This is also a very flexible process because you're not spending a lot of money on custom tooling. You could actually adapt these same machines just with different molds to build the larger aircraft that are further in our pipeline in the future. So we're super excited about some of these discussions that we're having, and we hope that by next Hangar Day, when you come here, we will be showing a lot more about this. So we're actually starting to approach the end here, and we obviously have an important thing left. But I just want to recap a little bit what we've talked about. We've talked a little bit about how the independent hybrid system is a revolution in propulsion that allows us to fly all electrically for short flights, but also great performance and great fuel reduction for longer flights. We've talked about how we were adopting a product development, an iterative product development process where we fail fast, we fail forward, and we learn. How we were inspired by the developments coming from the space industry and from the electric automotive industry. And finally, we've just glimpsed a little bit at how we look at the future of production. And together we think that these things are going to form the next paradigm shift as we bring aviation to the 21st century. So that's it for our presentation. Before we go into that door and look at the aircraft, I'm going to invite our chairman, Mr. John Slattery, upstage to give some closing remarks.
Thanks, Anders. I spent 10 years at Embraer, largest regional aircraft manufacturer in the world. Spent the last 4 years GE Aerospace, the largest engine manufacturer in the world. One thing I learned is it's our people that make us fly. Ladies and gentlemen, stand for one moment, face our colleagues, and let's just give them a round of applause, please. Thank you. I flew in from New York last night, late, and had a late dinner with my friend Zaid, who flew in from Riyadh to join us here, and we're honored to have you, Zaid. We talked about the common denominators of great companies. It's easy, we understand culture. You could see the humility. I wanted you to stand and clap for our colleagues, and even our colleagues were clapping for us to thank us for being here. So culture, tick. Great product is the second strong underpinning of great companies. Anders is going to lead us in a moment to see what is amazing. But the third leg of what's critical for great companies is to have a noble cause, have a mission that gets you out of bed in the morning and really gets you focused and grit. Building an aircraft is hard. I've done it before. My job on the board is to both challenge and coach the management teams. I've gone all the way from writing a business case to entering an aircraft into service, and I've done it with some people that are sitting here and some of you up there when I lived in San Jose dos Campos down in Brazil. So this is really hard. But people here, I was sold on this company and this vision by Anders when he and I had our first conversation a little over maybe 2.5 years ago. And he talked about that dual mandate of democratization of travel, so bringing travel back to places where it's disappeared from, and also the noble cause, that fine mission to decarbonize the future of flight. These are small aircraft. They're tributaries. But tributaries feed streams, and streams feed rivers. If we don't iterate and attack that problem, that beautiful gift of flight that allowed you, Ziad, to fly in here last night, allowed me to fly in, and most of you that have come from around the world to join us, that gift of flight just won't exist in the future. So we need all the stakeholders. We need sovereigns. We need our suppliers. We need investors. Most of all, we need you that are getting up day in and day out, iterating. It is not easy. It's bloody hard. So thank you very much. Anders, over to you. Lead us next door. Thank you, ladies and gentlemen.
All right, who's ready to see an aircraft?
I just have to congratulate Hangar Aerospace on a fantastic event. Today, to be able to see this marvel of technology be in full scale is extremely, extremely good.
I feel super inspired by the day, very optimistic. HART, for me, they are definitely part of the revolution that is going on in aviation right now.
There's just nothing out there like this. There's no other company that have anything like what HART announced today.
I feel hopeful, and you need to work to create the hope. And one of the examples of that is right behind me at the moment here at HART Aerospace.
My impression of today is I'm absolutely overwhelmed. And I think this is very, very much helping the industry in envisioning where are we going? Well, we're going here.
Amazing. It's very spacious.
HART Aerospace is leading the way forward to fossil-free aviation, and I think it's very inspiring to be here today.